All right, folks. Today we are going to learn how to solve quadratic equations. By using the quadratic formula. All right, so a quick review of what we did yesterday. Yesterday we learned about a number called the discriminant that will tell us the number of solutions that a quadratic equation will have and whether those solutions will be real numbers or imaginary numbers. The discriminant formula is b squared minus 4ac. And what we learned is if the discriminant is greater than 0, then we get 2 real solutions. If the discriminant is equal to 0, we get 1 real solution. And if the discriminant is less than 0, then we get 2 imaginary solutions. And I told you all today that we would take this one step further and actually learn about the quadratic formula. So, the quadratic formula is used to solve quadratic equations. That equation must be in that form that we always want it to be in. So ax squared plus bx plus c is equal to 0. So you still want the equation equal to 0, and you still want those other 3 terms on that other side in that specific order. Now here is the quadratic formula. The quadratic formula starts out x equals, because that's what it's used for. It's used to figure out what x is. And it looks like this. It's the opposite of b plus or minus the square root of b squared minus 4ac, and then all of that is over 2a. So the opposite of b plus or minus, that's what will give us the 2 solutions if there are 2. The square root of b squared minus 4ac, and then all of that is over 2a. Now, here's what I want to point out to you. This part of the quadratic formula should look familiar to you. b squared minus 4ac. That part of the quadratic formula is the discriminant. So I want to point out right from the get-go that the discriminant actually is in the quadratic formula. It's part of it. It's the part that is underneath that square root. All right, so what I'm going to do here is some examples that show you how to use this formula to solve quadratic equations that look like this. All right, so here's the first equation we'll solve. We're going to solve x squared minus 10x is equal to 11. All right, now the first thing that I want you to pay attention to is what we always pay attention to. Is this equation in the right format? Is it ax squared plus bx plus c equals 0? And I can see that it's not, because instead of being equal to 0, it's equal to 11. So the first thing I have to do is fix it. I have to fix it so that it looks the way I want it to look. So we're going to subtract 11 on both sides and make this equation x squared minus 10x minus 11 is equal to 0, which makes a equal to 1 b equal to a negative 10 and c equal to a negative 11. So that's going to be our first step. Our first step is going to be to get the equation into the format that we want it to be in, so that we can identify A, B, and C. Now, the second thing I'm going to ask you to do is I'm going to ask you to calculate the discriminant, so we'll know up front how many answers this thing should have and what kind of numbers those answers should be. So we're going to do the discriminant. So for B, I'm going to plug in negative 10, which makes this negative 10 squared, minus 4AC. That'll be minus 4 times 1 times negative 11. Now, you all know that the first thing we're going to do is the exponent. So first we do a negative 10 squared, which is 100. And then we're going to do this multiplication. So we're doing a negative 4 times 1 times a negative 11. So negative 4 times 1 times negative 11 should be a positive 144. Oh no, excuse me, that's not 144, that's 44. I'm thinking ahead and trying to go ahead and add. So negative 4 times 1 times negative 11 should be a positive 44. And then, of course, when I add 100 plus 44, that's when I get 144. So there is my discriminant. Notice it is greater than 0, which means this problem should have 2 real solutions. So, to recap what we've done, first we got the equation into the right format, identified A, B, and C, and now we have calculated the discriminant, and we've determined that we're going to have 2 real solutions. So now here comes the next step. Here comes the new part. We are going to use the quadratic formula to actually solve this equation. All right, so you all know with formulas, the trick is to plug the numbers in to the right places. So here we go. First, we see the opposite of B. My B is a negative 10, so when I do the opposite of B, that's going to be a positive 10. Then I have plus or minus the square root of B squared minus 4AC. B squared minus 4AC is the discriminant. I've already done that work over here, so I know that that's going to be 144. And then all of that is over 2 times A, which is 2 times 1. So once I have everything filled into my formula, I end up with 10 plus or minus the square root of 144 over 2 times 1. Now, once you get the numbers filled into the formula, you're going to be simplifying. And when you simplify, you're going to start by simplifying the square root, which we learned how to do a while back. We're in luck here because 144 is a perfect square, so you may want to grab that perfect squares list. We haven't used it in a while, but we will be using it today. So 144 is a perfect square, and the square root of 144 we know is 12. So this is going to be 10 plus or minus 12 all over 2 times 1, which is just 2. So simplify that square root after you get things filled in. Now, keep in mind, we're supposed to get 2 real solutions for this problem. And right here, this plus or minus is what's going to give us those 2 solutions. So here's what we've got. X is either 10 plus 12 divided by 2, or X is 10 minus 12 divided by 2. So 10 plus 12 divided by 2, or 10 minus 12 divided by 2. And again, I get those 2 answers from this plus or minus sign right here. Here's the plus version, here's the minus version. And now what we're going to do is work these 2 out as much as we can. All right, so first, I know over here I can do 10 plus 12. That's 22 divided by 2. And I can do 22 divided by 2 and get x equal to 11. And then on this side, I can do 10 minus 12 and get negative 2. And then negative 2 divided by 2 is a negative 1. So here are my two solutions, and notice they are indeed real numbers. So in this equation, the solution would be x equals 11 or negative 1. So I filled everything into this quadratic formula. I simplify the square root first, and then I break this apart into the two answers and work it out as much as I can. And we'll see in a few minutes that you can't always work it out as much as we did on this one. But this one's nice and easy. 11 and negative 1 are our two solutions. All right. Let's try a second problem. All right, for this one we're going to do x squared plus 16 equals negative 8x. Now, again, first things first, we're going to make sure that this thing is in the format we need it to be in. We want it to be ax squared plus bx plus c equals 0. And this is not equal to 0, so we're going to fix it. We'll add an 8x onto both sides so that it's equal to 0. And then on this side, we'll arrange it so that it's x squared plus 8x plus 16. So there's my problem all set up, ready to go. I can see in this problem now that my a is 1, my b is 8, and my c is 16. So get that equation looking the way you want it to look and identify what a, b, and c are. Now, next step is to calculate the discriminant. So we're plugging in 8 for b, so this is going to be 8 squared minus 4 times 1 times 16. This is all just plugging the numbers into the right places. All right, exponent first, 8 squared is 64. Then we'll multiply negative 4 times 1 times 16. That is a negative 64. And 64 minus 64 is 0. So notice this time we have a discriminant of 0. That means we should get one real solution. Now, time to use our quadratic formula to actually figure out what that solution is. So I'm going to write down my quadratic formula, and now I'm going to fill it in. So the first thing I want is the opposite of b. b is a positive 8, so if I do the opposite of b, I'm going to get a negative 8. Plus or minus the square root of the discriminant. I've already done the discriminant. I know that's 0. And then all of that will be over 2a, so again 2 times 1 in this situation. So negative 8 plus or minus the square root of 0 over 2 times 1 is my formula after I get it filled in. Now remember what I said. Once it's all filled in, work on the square root first. The square root of 0 should be easy. The square root of 0 is just 0. So we get negative 8 plus or minus 0 over 2 times 1. Oh, and I'm going to go ahead and make that 2 times 1 just a plain old 2. Let's go ahead and do that multiplication. Make life easy. Now remember, you've got here plus or minus. So there are actually two things going on here. X can be a negative 8 plus 0 divided by 2, or x can be a negative 8 minus 0 divided by 2. So all I'm doing here is I'm taking this plus or minus and splitting it apart so that I can see both options. But here's the deal. Let's work this out as much as we can. We know what negative 8 plus 0 is. That's just negative 8. And negative 8 divided by 2 is a negative 4. And then likewise over here, negative 8 minus 0, still a negative 8. divided by 2 gives us negative 4. So notice, there's only one answer for this. I don't have to do the plus 0 and the minus 0, because it doesn't matter whether I do negative 8 plus 0 or negative 8 minus 0, it's still just going to be a negative 8. And a negative 8 divided by 2 is going to give me negative 4. So here is your one real solution, x equals negative 4. And that's happening because this square root of 0 is 0. And it doesn't matter whether I add 0 or subtract 0, I'm going to get the same answer. All right, so there's our second example. This is really just a lot of filling in formulas and simplifying. Okay, for our third problem, let's do 2x squared plus 6x minus 7 is equal to 0. Now, you'll notice on this one immediately that this equation is ready to be solved. It's in that standard form, ax squared plus bx plus c is equal to 0. So I don't have to do any work on this one. The a is 2, the b is 6, and the c is a negative 7. So next up, I'm going to calculate my discriminant. All right, for b squared, looks like I'm going to have 6 squared minus 4ac is going to be negative 4 times 2 times negative 7. All right, exponent first. 6 squared is 36. And now I'll do my multiplying. Negative 4 times 2 is negative 8, and then negative 8 times negative 7 is a positive 56. And then 36 plus 56 is going to be 92. So we get a discriminant of 92. Okay, so our discriminant is greater than 0. So that tells us that this is going to have 2 real solutions. And now we can actually use our quadratic formula to find out what those solutions are. All right, so starting out with the opposite of b, the opposite of 6 would be negative 6, plus or minus the square root of b squared minus 4ac. We've already figured out that that's 92. And then all of that goes over 2 times a, which will be 2 times 2 this time. So x is negative 6 plus or minus the square root of 92 over 2 times 2. Now, as usual, when we get to this stage, we want to work on this square root. So I'm going to pull him off here to the side. Now this time, 92 is not a perfect square. So what you're going to want to do is split it apart into 2 square roots, with one of them being a perfect square number. So you need to go to that perfect squares list and find the biggest number in that list that 92 is divisible by. And that just so happens to be the number 4. 92 is 4 times 23. So you're going to break that apart into the square root of 4 times the square root of 23. The square root of 4 is 2. Square root of 23 we don't know. So the square root of 92 is going to become 2 square roots of 23. And folks, we're using a skill that we worked on before Christmas of being able to simplify a square root. So this right now is negative 6 plus or minus 2 square roots of 23. And then I'm going to go ahead down here on the bottom and do the 2 times 2 and make that 4. So after you get the numbers filled into that quadratic formula, then work on the square root. This time, notice we still have a square root in our answer. So again here, this plus or minus sign tells me I'm looking at two things. X can be negative 6 plus 2 square roots of 23 over 4, or X can be negative 6 minus 2 square roots of 23 over 4. It can be either one of those things. Now, like I've said on both of the examples we've done so far, at this point you should work these out as much as you can. So, do we know what negative 6 plus 2 square roots of 23 is? No, we don't. We can't add here because these aren't like terms. So this is going to have to stay like it is. Likewise, we can't do negative 6 minus 2 square roots of 23 either. I don't know what that is. I can't work it out because those aren't like terms. Now, I do need to say one more thing about this. You can't work these out, but you do need to see if they will simplify. Now, I want you to listen to what I'm about to say very carefully. When you can't work it out, and you're trying to see if it will simplify, what you need to do is look at all three. Now notice this, all three of your outside numbers. The only number you're allowed to ignore is the one that's inside the square root. So you look at all three of your outside numbers, and what you're looking for is there's something they will all divide by. So 6, 2, and 4 will all divide by 2. So that's what we're going to do. We're going to divide all of these by 2. So negative 6 divided by 2 would be a negative 3. Oh, shoot. I didn't mean to put plus or minus. So negative 6 divided by 2 would be 3. 2 divided by 2 would be 1. And 4 divided by 2 would be 2. So there's your first answer. And then over here, all of these will divide by 2. So we're going to get a negative 3 minus 1 square root of 23 over 2. So these would be my two answers. Still real numbers. They just look a little messier than those first two examples that we did. So with that square root, simplify as much as you can. All right, one last problem. Let's do x squared minus 6x equals negative 10. Now on this one, you can see that your equation is not in the form it needs to be in. It is not equal to 0. So that is the first thing we're going to have to fix. We're going to have to fix this so that the problem is equal to 0. So to do that, we'll add 10 to both sides. So that's going to give us x squared minus 6x plus 10 is equal to 0. So a in this problem is 1, b is negative 6, c is 10. All right. Now that our problem is set up and ready to go, we will do the discriminant part of this. So let's see, for b we fill in negative 6 minus 4 times 1 times 10. Negative 6 squared is 36, and then negative 4 times 1 times 10 is a negative 40. 36 minus 40 is a negative 4. So we get a discriminant of negative 4, which means we should have two imaginary solutions. And so now we'll go to the quadratic formula and actually get those solutions. All right, so we'll start with the opposite of b. The opposite of negative 6 is 6, plus or minus the square root of our discriminant, which was negative 4. And then all of that's over 2 times a, which is 2 times 1. So x is going to be 6 plus or minus the square root of negative 4 over 2 times 1. Now, the square root of negative 4 needs to be simplified, and you need to remember from before Christmas that a square root of a negative number is what causes us to get that imaginary number. So we're going to take this first and make it the square root of negative 1 times the square root of 4. The square root of negative 1 is the imaginary number. So an I, and then the square root of 4 is 2. I times 2, remember we're going to write as 2I. So the square root of negative 4 is 2I. 6 plus or minus 2I. And then all of that's over 2 times 1, which is 2. So your imaginary answers are happening because you're being asked to take the square root of a negative number. Now, x can be one of two things. It can be 6 plus 2I divided by 2, or x can be 6 minus 2I divided by 2. Now, again here, we're supposed to work this out as much as we can, but I can't do 6 plus 2I. I don't know what that is. I can't do 6 minus 2I. I don't know what that is. But here's what we can do. You can look at all three numbers to see if there's any possibility of reducing. Well, 6, 2, and 2 all divide by a common factor, and the answer is yes. They'll all divide by 2. So this is going to be 3 plus or minus, or not plus or minus. Why do I keep wanting to do that? Sorry about that, folks. It's going to be 3 plus 1I over 1, and I don't need to put that over 1. And over here it's going to be 3 minus 1I, and that would be over 1. But again, I don't need to do that. So 3 plus I and 3 minus I would be the two solutions. All right, so this is how you would solve quadratic equations using your quadratic formula. Give the problems today a try, and please let me know if you have any questions. This will be your last assignment for the semester. Please remember that all assignments are due by 5 p.m. tomorrow, which is Wednesday, January 20th. I want to thank you all for a good semester. You all have handled virtual learning beautifully, and I appreciate the effort that so many of you have put into this. Certainly wish that I could have had you in this class under different circumstances, but I've enjoyed working with you, and if there's ever anything that I can do to help you, please don't hesitate to call on me. So, thanks a bunch, and again, let me know if you got any questions or if there's anything I can help with.